All right, in this video, we're going to work comprehension check problems number 6 and 7, and I'm going to show you how to do it using the proportion method that I taught you in the video for today's lesson. So comprehension check number 6 says a chemist reacts 10 grams of copper and 3.21 grams of sulfur to make 9.56 grams of a blue powder. He also has some leftover copper. How much of each element should he react to make 100.4 grams of the blue powder with no leftovers? So if I take that information, I started out with 10 grams of copper, 3.21 grams of sulfur to make 9.56 grams of powder. And the problem says that I do have some leftover copper. So the first thing that I need to do is figure out exactly how much copper am I going to use to make this compound. So I go down here. I know that initially I started with 10 grams of copper, 3.21 grams of sulfur to make 13.21 grams total. Since I only made 9.56 grams of the powder, when I subtract that, I end up with 3.65 grams of leftover. It had to go someplace. We know it can't just disappear. So that 3.65 grams extra here was the leftover copper. So I'm going to take that 3.65 grams, I'm going to subtract it from the initial 10 that I started with. So that means that I've used 6.35 grams of copper. Now, if I'm trying to make 100.4 grams of the powder without any leftovers, what combination do I need to use? So I'm going to start with the copper, 6.35 grams of copper to 9.56 grams of powder, because that's the ratio that I came up with up here. And I know that I want 100.4 grams of the powder, so I'm going to set up my proportion. Remember, the powders have to go on the bottom on both sides, so the copper will end up on the top in both sides. When you punch it into your calculator, you're going to say 100.4 times 6.35, and you're going to divide that by 9.56, and that will give you 66.7 grams of copper. You should have 3 significant figures because that is what I have in both of these. That's what I came up with here when I subtracted as well. Okay, so 66.7 grams of copper. To find out how much sulfur I need, I'm going to use exactly the same type of proportion, only this time I'm putting the 3.21 grams of sulfur on the top to the 9.56 grams of sulfur on the bottom. Again, I'm trying to make 100.4 grams of powder. Notice that these two proportions are the same except for what goes on the top and the left-hand side. And you should see that pattern emerge in all of these types of problems that we're working. So when you punch it into your calculator, 100.4 times 3.21, because those are diagonal from each other, divided by 9.56, that will give you 33.7 grams of sulfur. Now you want to make sure that that answer makes sense. So you take the 66.7 grams of copper, you add that to the 33.7 grams of copper, you come up with 100.4, and that's what you were supposed to come up with. Okay, so there's comprehension problem or comprehension check number 6. Comprehension check number 7, a chemist reacts 50 grams of sulfur with 50 grams of oxygen to make 83.4 grams of a gas, along with some leftover sulfur. Okay, so I'm going to stop right there for a second. And if you look here, here's my 50 grams of sulfur, my 50 grams of oxygen, my 83.4 grams of the gas. I know that there's leftover sulfur, so the 50 grams each of the sulfur and oxygen makes 100 grams to start. I have 83.4 grams to finish, so that's a difference of 16.6. So that's how much leftover sulfur there was. When I subtract the 50 grams of sulfur minus the 16.6, that tells me that I used 33.4 grams of sulfur. Okay? Now, the second sentence of the problem then says, in a different experiment, he reacts 20 grams of sulfur with 30 grams of oxygen to make 49.9 grams of a gas, along with some leftover oxygen. Are the two gases he made the same? So in the second part of the question here, here's my 20 grams of sulfur, my 30 grams of oxygen with leftovers. You notice this time I had leftover oxygen. First time I had leftover sulfur. 49.9 grams of a gas. The weight of the initial ingredients was 20 grams of sulfur and 30 grams of oxygen, which makes 50 grams total. I had 49.9 grams at the end, so that's a 0.1 gram difference. The oxygen was what was left over, so I'm going to subtract this 0.1 gram from what I started with. So that means I used 29.9 grams of oxygen. Okay. The question then is this powder the same as this powder down here? And the way I'm going to check that is to see if the ratios of sulfur and oxygen to each other are the same or not. So in the first problem, I used 33.4 grams of sulfur and 50 grams of oxygen. In the second experiment, he used 20 grams of sulfur and 29.9 grams of oxygen. And when you set this up, you want to be really, really sure that on both sides, that the left side is your first compound, the right side is your second compound, and that on both of them, you've got sulfur on the top, oxygen on the bottom. If you flipped it the other way, it's fine as long as you have oxygen on the top, sulfur on the bottom. You just want to make sure that the same element is on the top on both sides. Okay? So if I'm trying to figure out, are these two the same ratio, I'm going to divide these two. So if I divide this side, I get 0.668. If I divide this side, I get 0.669. They're different back here because of some rounding issues, but that is close enough, certainly, for us to say, yes, they are the same gas.